Hey everyone, it's Matt Dickinson here. Welcome back to the channel. If you are one of my students, welcome back to some more CAD work. If you are interested in exoskeletons, and in particular this project, the rebuild of Hardiman, welcome to the overall project. This is a bit of an overview. Hardiman, built in the 60s, vanished off the face of the earth in the 70s, and now is floating around somewhere. I've been looking for this for a long time, and not on my own, so some friends from ASTM and other places as well. We've all been looking to see if we can find it, just on the real focus of can we actually find it to aid in understanding, because the one thing to remember is this would be the world's first fully powered exoskeleton. Didn't work. The arms did, but the legs were very unstable and they would often fall over. So that's what this project is really about. Apologies that I have not set up a video sooner. Just some other things going on. So without further ado, I don't intend for my videos now to go on for too long. So what I'd like to do is start to shorten them down a little bit. So yesterday I actually did some recording, and yeah, I had some issues with my audio, and as such had to delay my output on this next video. But without further ado, let's shrink this down. Shrink right down to here. So if you remember, as a bit of a catch overview, this is where we were, the slave hand. Now I have actually made some modifications, but we're going to go through this and navigate our way around this to take a look at what I've actually done and the types of changes that we're actually looking at. Okay, so what I'd like to do first though is, because of the changes that I made yesterday, we're going to take a look at some of the paperwork, because now we have our overall, we need to start ironing this down to the type of design that we'll be looking at. So a detailed design. It's all about the intrinsic pieces that we need to know. So let's bring back to the original paperwork. We are in July of 1969. And we are in section 5, which is the definition of materials, operation, things like that. Basic shapes, the overall sizing, joints, numbers, parameters, controls, things like that. Okay, so before I go into too much of a side note into what I want to do, let's just take a look. So we know it was made of 6061 aluminium. This is just because of its availability and its weight. We also know that a minor amount was steel for pins, shafts, hardware, accelerator joints and cylinders for the walls was used, which is fine, you know, we know that. However, here we go. Anti-frictional bearings were used for most rotating joints. Wherever possible, these are airframe bearings. These bearings are designed particularly for heavy load, with random rather than continual motion. The design for these bearings is taken as 66% of the aircraft limit load as defined in the MLB 7949A. So what is that? So let's have a quick gander. As I said, I don't want to go too much on this side of things, but what I'll quickly do is just, let's call that up. Go to there and let's have a quick look. So if we come onto here, what it's actually referring to is a specific military specification of a ball bearing. So what is a ball bearing? For those of you who've done this inside out, you will know this. At least you should know this. This is what you class for your aircraft ball bearing. Obviously you have your inner casings, you have your inner linings. Apologies. You have the casing here and here, and then the overall interface of top and bottom. This is to just prevent as much dust penetrating the actual design as possible. And what you've got is you've got balls that are running on the inside. Now, let me just see if I can find a quick breakdown. You don't see it too well on here, but that's the type of design that you see with your overall rotational bearings, ball bearings to look like that. So because we know that it's ball bearing, so let's just go a little further. Let's go ball bearing. There you go. So this is a great key example. So there's your ball bearing, ball on the inside, but some of them come with a casing, almost a wrapping around it, so you can't get a lot of dust penetration, like this type. Now, anybody who's used a skateboard, so much you'll see these on. These little ball bearings are phenomenal for what they do. But what they were using was a military grade, an aircraft grade one. So what we will do is we will go down the same road. What we're actually going to do is we're going to use one that I actually pre-selected. In this case, it's a 61801. So let's have a quick look at that as a bearing. So this is a 61801, so 61801 bearing. And there you go. So this is the actual one that we're looking at. Now the 61, the size of this is 21 millimeters, because I'll show you why in just a moment. Overall performance of this, very off the shelf stuff, very, very straightforward to get hold of. So we have a 606101, and we also have a 6800ZZ. So let's go 6800ZZ bearing. And there you go for this one as well. What you can see here is it has an ID of 10 millimeters and an OD of 19 millimeters. Very much off the shelf, very available, easy to get his hands on, not a problem. So they're the two there. Now that is what we will use in this particular session right now. Now I've sourced these by using somebody who's already modeled these on GrabCAD. If you know the dimensions for the actual bearing that you're interested in, it's quite good to use that as a reference, because it's a quick way of getting your dimensions. For anybody who's never seen this, I'll quickly show you. I'll go through GrabCAD. It's just a quick way of pulling your dimensions when you need it, and you can pull quickly what you're after. It depends what you're looking for. Right. So that's one thing. So that's one element which we will take a look at in just a moment. And then the other thing they refer to, in some cases the bearings are larger and standard airframes are needed. Basically they've had to use a bigger bearing where needed. I think we will hit that, but it's okay for what we're going to do right now, we won't. And then we've got a Teflon linear monoball bearing. Now, as a student, I thought that, when I was a student, I always thought that was a bad spelling. I mean, I'm dyslexic, so you kind of go, yeah. So if I bring this back up, now show you quickly what a Teflon. Oh yeah, see, I had a search in earlier. So a Teflon ball bearing, linear ball bearing. Now this is a cracking example. So let's look at that. You see how we've got this in here. You see how it can shift around its central axis. It's not held to one spot. You can get these embedded in things such as posts. These posts are very common to have been called rod ends. But to get the linearized ones means that you just have the normal fitted in, and then you can use it to move around. It allows you to shift around axes. So for robotic applications, these bearings are phenomenal. And this is the type of bearing that we'll go for. And you look at some of these, what we're looking at nowadays, they are peanuts. In the 60s, these would have been very expensive. So that's now set out the actual work that we're looking at. Now, what I'm interested in now, though, is I'm just going to go back to some images, actually, just because. Let's just take a quick look. So if I jump to the images, what I'm actually interested in now is if I come to here, we're coming back to the classic one. So this now has been coined for when we're going to unveil this. So I'm now keen. But if you look, can I zoom you in even more? Of course I can. If you look here, that is definitely a bearing interface, and also here. So our focus now. So what I think this is I think we've got a bearing on the inside of both sides of that actual unit. Then what it does is it pushes. We've got a piece that pushes in, and I think they've locked it into position. So what we're going to do is follow the same thing, and then we've got the same here as well. Now these rods, I'm going to model these, and I have modeled these in a quick overall view to actually give us a size-wise. But I'm going to take you back through and show you where these modifications sit. So if I come back, let me just update that. You know what it's like with the lightning bolts. So what if I just minimize here and minimize here? So what I'll do is, for this now, we're actually no longer focusing on the wrist or the control box, or yeah, so the wrist and control box we don't need for the minute, so I'll hide that back. What our focus is now is the thumb. So what I did is, if I look for the 6181 version. So if I show these, if I go visible, right. So what I'll just quickly do is pop this open. So let's have a quick look. So this is the bearing. This is not my model. This is a reference model that I'd used from GrabCAD, and then ensured that the sizing was correct. So if we have a quick look for the overall sizing, internal recommends to be exactly 12 millimeters as predicted, and then the external actually is whoa, it's me rushing, and the external dimension is 21 millimeters, and then as I mapped it, but and that is now the bearing. The thing to keep in mind with this is I'm using this to just give me geometry to make sure it's gonna fit when I actually do something. So just so you can see for your own information, this bearing itself was actually modeled as a solid piece, which I think is a good idea. Just because you don't, if you're not interested in that bearing, why have all that intricate information on the inside? So let's drop that out, save that in, and then OK. And let's introduce the other one to the other side. So I've got visible. And now what we've got, two bearings on each side. Now the thumb pin. If I just bring in the thumb pin. Now this thumb pin, if I just open, let's just, in fact, I'm just going to hide the main hand for the minute. Hide that for the moment. Right, and now what you can see is this is actually sitting. Can I put you there? Ah, that'll do it. That'll do it. So if you look there, you can actually see it's actually sitting in flush with here. Now this is just because what I want it to do is to interface with the actual thumb, but I just want it to freely have motion, because we've got to remember our overall performance. This front hole is going to sit to actually cause actuation around the main area of the thumb. This second back piece here is the actual main piece that interfaces to the upper piece. So what all this needs to be able to do is freely move, but based on what they've made in recommendations for size wise, they'd use these bearings, and the interface between the whole thing across here is these two bearings acting on this bridge, if you will. So I made the decision of that for me will probably be how they would actually approach this. And this pin is going to have to be broken down to become a little bit more feasible. But yeah, all it will actually be from that pin is where it's actually engaged, and then it'll be unscrewed and screwed in place. And what I was keen to be able to do is try and capture the overall appearance of the actual image, that motion, because the overall the focus of this is to try and capture the same essence, if you will. And you can see here, once that's actually broken down into a sub-assembly, I'm pretty happy. We're going to be looking pretty good at that spot. You see now on my fillets. If you look at my fillets that I've applied onto these edging, I think my fillets are too big. Look at that. It just looks too round, if you will. So that's going to be broken down. Not right now, but that is going to be broken down. Now the next thing is the thumb. So if I just break into the thumb, can I move across here? There. So we notice here we've actually got this area here. Now the thickness of there, one thing I did notice is, well, you look there and there, these are the same thickness. So it's either going to be us modifying this to ensure that we are the same size on both sides, or not. Now you'll see here I've already made that modification. Again, this was the gift from me recording and forgetting and having problems with my audio. So I'm going to now move over to this. Now this is a modification that I'd made, and the most important thing is that the rod that interfaces across here from this point to this point will remain open, and to allow me to have a linear actuator that moves up and down this clear line, and allowing the thumb to exert its position, which is clearly needed through that process. What I did is I selected a bearing which was off the shelf. Now this is the bit where I've been very unsure. I'm just not quite 100%. So this is a 6800ZZ bearing. So let's take a look at it. Push that into play. Now the other thing that we did that again I didn't record because I'm a wally is I'll just open this up. So this section here and this section here, if I just hide this, suppress the feature for a moment, that is originally what we had. Now the issue that I had is the thickness. We either made this so thick that it would allow us to embed them bearings, or we actually made a jacket, a housing if you will, a hub for the bearing to sit in. And given the time that it was, and given the thickness of that is observed in Moshe's image, I don't think that, as I really take a look, I don't think that it's too much to imagine that there is some type of housing at the back of here. Just because any decent bearing to that size, given how specific and how well engineered a lot of what they were doing was achieved, I would strongly recommend that we actually introduce that to it. We can revisit, and we will revisit again and again for that, because there's nothing in stone right now. That's the beauty of doing what we're doing. We've got some freedom of motion. So I'm just going to save that back in and then come back across. Right. So then from here, what I did is I've introduced my bearing, and also introduced another bearing here. So all I've done is use joints. So to show you where I am, just use rotational joints because that's all they are, and then I'm getting a bit more of a detailed representation. Now the next thing what I was looking at is, if we just pop back to Moshe, we just zoom into Moshe a little bit more, you look here, you can see that it's open, but you've actually got these end caps here. I'm gonna go with the idea of introducing another pin. So what I've done is created another pin. This pin, granted, the way it's sitting, I just don't know. I mean, I look at how that looks here, you look at the actual extrusion there, given the light that it hits on, I don't think it's that thick. I don't think it's as thick as what this is. So what I'm going to do is quickly open that and see if we can just take a look at how that was actually extruded out. And if I edit, I've gone 3 millimeters. Let's just drop it to 2. And I know, if anybody's watching this, you kind of go, whoa, is it though? Is it? It's a good question. So if I go 1.5 to not take it to the edge, it's just so we have that behavior across it, and I'll save there. I'm probably going to print this for our next session so we can all take a look at it and see and make our own decision. Now you see how it's interfacing there, you see our overall bar here. Now let's just get it to that position here, like that, something like that. And then what I'll do is, can I actually just pick a face? Pick a face? I want to pick, no, I don't want to do that, So can I just add? No, I can't. Cancel. No, okay. I'm gonna need to just change that. It's that point here I don't like. But anyway, so right, what we're actually after, what I'm after doing here is getting a rough generation which is similar to the famous Moshe image. So if I just bring that across, Granted, that's a little bit higher, that'll be a bit lower, but what you start to see is that this will fit. These are actually fitting. That one I'm more happier with. You can see there looks like a countersink there to me. Here, I'm not sure yet, but I think that we're getting there with this. This is starting to look as it would. The pin itself, I think this pin is custom, and then I think what they've done is built onto it. Interestingly though, what's really caught me out, if I'm honest, is if you look at this now, if you look at the actual point here and then you look at the point here, this isn't there anymore. That is suggesting to actually be here, and that isn't there. But the interesting thing is, and this is where I find an inconsistencies actually in the data, which I shouldn't say that because it's almost quite wrong of me to say that, but I'm actually finding some initial problems. So if let's just find it. Apologies. This one. There it is. Look at that. So that is our slave thumb. Mark, point, point to point. Interesting, right? So if we bring this back to here, oh my giddy aunt, I've just realised something. I've realised inconsistency. Look at that. That is how it's controlled. Oh, I'm in the wrong position. You look at that, then look at that, then look at that. You can see there it's actually, oh, it's actually hanging inside, so that's on the inside. Oh my days, I've just realised what this is. Oh my days. Right, okay, so that just means I need to be really looking about moving this to here. That's just caught me off guard, but I do need to look to making that to move across, and that would explain why when it's closed it's more linearized across here, because it is sitting over that particular point when it's actually in that hinge. And this is good news though. The exciting thing for me in this image is, if that's our hinge, which evidently this is our hinge, it means in this image here, it means the inside of here is hollow. It has to be. Or else how are you going to actually drive this? Look at that cut there. I wasn't sure if that was a cutout. That is a cutout. We are looking extremely good right now. If that's the actual hinge that we're looking at, which I think we are, because you can see them key markers where it's been panned out, and I think that's so they can attach the actuator to the upper next point. That would suggest it sits on the inside, and all I need to do now is move that across. And that's where it's going to be a little bit tricky, because it means some of the work that we've done here needs to get moved around to allow it to suit that little bit more. But we're looking a little bit better at that point, I would say. The only thing I'm not too pleased about is my holes here and here. My axis points, I think they're too small given the overall sizes. Not an issue, but yeah. Right, so that is the bearings. So they're the bearings. What I'm going to magically do with them, with the pure joy of wisdom and excitement, I'm going to quickly make that modification. So with what I'll do is quickly make this happen. So like this. So quickly on the revision. There's our center point of axis. There is the actual key point for the actual mount. That is the anchor to cause the thumb to move. So what I've quickly done, I've been sat here a lot longer than I thought I would be, is I've just gone through the thumb and took a good look at the thumb. And now I have updated version 2 thumb. Dun, 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 dun. So here now is the anchor of the new thumb. I'm thinking this might be centralized all the way through to create a good anchor there, but I'm not 100% sure yet. Some modifications I need to just make a little bit to make sure that this is consistent all the way across, because you see there, it doesn't seem to be right. So if I just quickly modify that, so I'm quickly modify that because I want that to be consistent. And if I just create a quick overview of there, and then do an extrusion for that, and then we're going to go right to there, to that particular edge, close that edge off nicely, and that's a little bit more like we're after. And I need to do an internal fillet on there, but I think that now meets more of the criteria of what that thumb was actually meant to be. So my angle here needs changing a little bit. So if I just bring this across, now we see there it's looking a little bit more of what it should have been from the start. This here is still a little bit unsure. You see there, I think that part comes as more smooth here, but one thing I'm pretty sure now is it is hollow. We have a hollow structure, and if we have a hollow structure, that now needs to be modified into here, which I will do. But that now brings us to the end of what we've actually been doing. So now we've noticed that the thumb needs changing, modifications have been put to there, we've done the pins, we've done the bearings, we're now getting a lot more detailed design that's been introduced to it. It's now starting to look like how it did in the 60s. We're looking really good, and yeah, the overall structure, the design of this is looking more like it. What you should quickly do, I forgot to show you all, is a quick look down to here. You'll notice now the plate between the two, same dimensional size, same thickness, because I think looking at the overall it was. But yeah, that is now the thumb almost ready to have a linear actuator fitted. The video next week, I will be a little bit late because I am now traveling. I will be flying to Washington next week to do some work out there. But I will be catching up as soon as possible. I may do a live video on the go traveling to Washington, but I will see how we get on. Other than that, I hope you all found this extremely useful, or to some level useful, and I hope everybody can see which way this project is going. Now it's starting to get the shape. It's exciting. Other than that, I hope you have a great rest of your weekend, and if you're a student, I will speak to you soon. And if not, I will speak to you next week. See you all. Thanks, guys.